Welcome back to the PVOP podcast. Today, our guest is ASIC. ASIC has a decade of experience in the energy and renewable installation sectors. Since the liberalization of the Spanish electricity market in 2009, ASIC has become one of Spain's first independent electricity suppliers. ASIC right now collaborates with and supports over 30 different electricity suppliers, and their clients collectively supply over 2 terawatts of energy annually to more than 8,000 supply points. They are also a trusted partner in the PVOP project, and we have them here to talk a little bit about the solution that they are developing for this project specifically. Thank you so much for being here with us, Ignacio. So first of all, I wanted to discuss a little bit more about the solution that you have for us, which is an AI-based electricity market prediction tool. Okay, so a market prediction tool. So how does volatility of electricity markets pose challenges for PV operators, especially with increasing renewable penetration?
Okay. The volatility in the electricity market is probably the most problematic issue that the PV operators and PV producers has to face in the next years. Okay, because due to the structure of the market, okay, at the end, all the technologies and the European market plays on the same market, okay, and no matter the cost that they have, okay, at the end they receive the cost of the last technology or the most expensive technology that has match or has a match in the market some energy. Okay, the problem here is that there are two different kinds of or main kinds of production technologies. One is the technologies based in falls. Okay, it means gas, coal, and so on. Okay, on the other hand, we have the technologies based in renewable energy, like aeolic one and photovoltaic one. Okay, at the end, the difference is that the first technologies has to fire some or burn fuel, okay, and this fuel has a cost. And the other hand, the aeolic and photovoltaic technologies has no fuel, okay. So the marginal cost of these technologies is really low. The problem is that in the market, in the European market, there is a duality, okay. At the end, the price could be really high, and it's higher after the Ukrainian war, okay, or could be really low, even in negative prices when there is a lot of renewable energy available. Okay, for example, windy weather, or here in Spain from March to July. Okay, that we have a lot of sun. Okay, and not so much demand. Okay. So it means that in several cases and several months, okay, these producers and specifically the photovoltaic producers, okay, receive really and not too much money for the energy that they sold in the market. Okay, we are speaking about there is a relationship between the average price in the market, okay, and the price that the producer receive, okay. And for example, for the last year here in Spain, the producer received over 42 euros per megawatt, okay, when the average market was 64 euros, okay. It means that they are receiving more or less at this moment the 70% of the market price, okay. Mm-hmm. The problem is that in the next years, okay, it will be harder for this kind of producers, okay, because there is more and more photovoltaic energy, okay, available in the market, okay, and the demand is now growing. Okay, at least here in Spain and the rest of Europe is the demand is flat, okay, and we need to to improve or to make greater this demand in order to make parallels ball growing. Okay, it means at the end that there is a extreme volatility. Okay, in the market that in a day you can find in the central hours of the day when the photovoltaic producers are selling all the energy produced by the sun. Okay, we can find price around €0, even negative prices. Okay, but we can find in only 1 or 2 hours later in the same day prices over 150, even €200. Okay, it's an extreme volatility. Okay, and for that reason, it's really important. Okay, to introduce several tools to these kind of producers that in the previous years they only go to the market and they only sell to the market and the price that matched in the market is good, okay, but now is not enough with that, okay, in order to make the assets, okay, at the end you can find some rentability to your assets, okay, and it's not enough, okay, with if you go directly to the market and expect the best prices, okay, due to this volatility and also the cannibalization in the central hours and several times inside the year. Okay.
All right. So you mentioned like there are some tools that you might use to address these issues, right? So like you are talking about some of the limitations of traditional electricity market forecasting models, right? So what
Mhm.
are the limitations, and how does AI address these gaps that we are talking about?
Okay, the limitation, the market, the question of the market that is that the market that we decide to have here in Europe is the marginalist, it's a marginalist one. Okay, it's not probably it's not there is no an ideal type of market. Okay, it means this is a market that, from my point of view, works fine. Okay, the problem is with in several countries, like in Spain, maybe not in France or on Germany. Okay, but for example, here in Spain is when everybody goes to the same market. Okay, because you can find another markets over the counter markets, bilateral markets. Okay, when the transaction are made between two parties. Okay, but going to the point. Okay, the question is that this is the daily market where the energy prices are fixed. Okay, but there is additional markets that are used in order to adjust the energy that the several parties that are participating in the electricity market. Okay, they need to adjust his programs. Okay, why? Because the electricity, okay, has to be consumed at the same time that it's produced. Okay, and me as a producer, as a retailer, or as a consumer, okay, makes a provision of the energy that I will consume tomorrow, for example. Okay, but usually I don't know exactly which will be this consumption. Okay, I make my best forecasting. Okay, but once in the day, okay, for example, I can see that it's hotter than expected, or I have several machines in my factory that are stopped, or something like that. Okay, and I have to adjust this program. Okay, and when you adjust this program, or the energy that you are consuming is less or more than expected, okay, the grid or the operators have to adjust to the producers in order to match in every second, in every time, the energy produced with the energy consumed. Okay, and for that, there are several secondary markets. Okay, that the operators, the transport operators in the several countries, okay, use it, okay, in order to match this spot energy, the consumption at and the production. Okay,
Mhm.
and these markets, for example, gives money to these producers that are able or are in the position to stop the production or to start the production. Okay, once this operator asks them to start or to stop. Okay, this is the secondary market, and these markets pays really, really well. Okay, or really, really uh, more money. Okay, than the daily market or the traditional markets. Okay, and are additional markets, as I mentioned before. Okay, you can go directly to the daily market, or you can expect or make a prospect of your price, okay, to sell this energy that you plan will be produced in the next 1 year, 5 year, 15 years, okay, to another party in the market, one retailer, consumer, and something like that, okay. But in order to do that in a proper way, okay, it's really, really important to have a really a good approach or a good estimation of the price that you will find in the next years, okay, on the several horizons, okay. And for that reason, it's really important the EA, okay. And also, it's more important than the last time because the previous years, the price analyze were based a lot in the prices of the of fuels, okay, for example, of gas, of petroleum, and so on, okay, and the actors makes the production, okay. But now is because this new type of energy depends a lot of the weather, okay, is probably you have to continue making prediction of price of oil and so on, okay? But also you have to make a lot of prediction of weather prediction, for example, okay? We have several mathematical models, okay, that do already that, okay? You have to expect no events, okay? For example, elections, like the last that we had in the United States, or the Ukrainian war, and so on. You have to um, even to prevent or to take into account that this kind of events could appear every time. Okay, and the tools, okay, are not an 100% exact tools, okay, but help us and help our customers and the producers, okay, in order to plan and to make a forecasting of at least of the big numbers, okay, in which the price will be moved in the next years, okay. Also, it's really important to use these new tools for these actors, okay.
Mhm. I understand. So basically, so the AI is going to make accurate market predictions, right? So and these market predictions will be for the next few years, right? So and how does this directly impact these the markets in the sense of like pricing, the storage, and the green interaction for the operators?
Yeah. This is the next step because once you have a good production, and we have to understand also, okay, that price production comes together uh, with the demand production. Okay, this is a really important thing to take into account. Okay, but going to the question, okay, I explained it before the different markets that we had. Okay, and if you have a good price production, okay, you can sell the energy that you will generate. You can sell in the best market for you. Okay, you can decide to sell part of the energy directly to the daily market, part of the energy directly to the for in a bilateral on over the contract to other party. Okay, and part of the energy in the secondary markets. Okay, also once you have a part of this market, okay, because the batteries, okay, it's also very interesting that you can decide when it's more interesting for you to charge or discharge the battery associated to the plant, okay. And this is really, really important in the example I gave before, okay, that in the same day you can find prices in the middle of the day uh, below around €0, even below €0, okay, and 2 or 3 hours later you can find in the same day prices over 150, €200, okay. And for that question, it's really important to have this forecasting of the price that you can find in the next day, okay, in order to decide, for example, is the probably the simplest example when you are speaking about these new technologies, okay, in order to storage the energy that you will produce in the middle of the day, okay, in order to this to charge use this energy to charge your batteries, okay, in order to discharge the batteries at the end of the day when the energy in the market is more expensive, okay. And this is the best example, okay, at what is really important to have this kind of production, okay. Um, and also, this is the example in the short term, okay, in that we call the arbitrage, okay, and in the daily market, okay. But the same is used, for example, when you need to give this support to the net that I speak before, when the operator needs to match the consumption with the production. Okay,
Yeah.
you can use also not only in terms of price, also because the price forecasting has to be joined or is joined to the demand forecasting. Okay, you can expect to anticipate when the market is has more energy than needed, or the opposite. Okay, and you can get the position that you that is better for you in terms of revenues. Okay, at the end you have in the previous years, you have only one tool in order to monetize to your plan. Okay, is to sell directly to the market, and now you have to build that we call the stack revenue. Okay, it means that I have several sources of revenues. Okay, not only the daily market. Okay, and for that, it's really important to have these AI tools. Okay, in order to have a proper forecasting of the price. Okay.
Yeah. So yes, I think that's yeah, definitely like using AI is something that is very interesting and it's growing right now, especially for these kinds of tasks like demand forecasting and so on. So talking about specifically and now focusing a little bit more on the solution itself, what distinguishes this AI-based tool in terms of its ability to model complex variables like what you mentioned, like weather, demand fluctuations, law changes? What do you think is the best characteristic of this AI-based tool?
Okay. There are several EA tools in order to make price forecasting. Okay, but that we have to introduce here. Okay, there are three points that, in our opinion, makes the difference with other EA tools. Okay, the first one is to introduce or to mix all these inputs, all these data inputs. Okay, that we mentioned before. Okay, for example, the weather forecast, storage demands, and so on. Okay. The second one is the regulatory shifts. Okay, that are really important because our regulatory shifts, for example, could introduce change in the market, could introduce cap prices, and so on. Okay, and you have to expect that this regulatory shift could occur in the future. Okay, associated to these regulatory shifts are the stochastics events. Okay, that I mentioned also below. Okay, that are relations with several events, important events, political events, natural events, and so on that could impact in the prices. Okay, And the other part is that um, the, this tool is not an isolated tool. That means when several developers makes this kind of tools, okay, these tools isolated to the other part of the system, okay. And we in this project are we integrating this tool in all the chains, the value chain of the photovoltaic plant, okay, including the batteries. Okay, that's really, really important because we have in mind from the first point from the beginning, okay, how we'll have to operate the battery, which is the the status of the PV plant, which is the stack revenue that is looking for the production of the owner of the plant, okay, and these kind of things that are also data that we are included and introducing in the EA tool, okay.
Mhm.
Uh, and probably is the most important things or the things that are really really different for other things that has been made in this field, okay, before, okay, that we have in mind from the beginning if the sensorization of the plant is good, which will be the maintenance that the plant will need, okay, in order to take into account also this data in our price predictions, okay, because we only not only we want to give this price forecasting, also we have to suggest to the operator, okay, which will be according this forecasting, okay, which will be the best way in order to operate the plant, okay. And there has it adds a lot of data, okay, for example data of which is the status of the batteries, for example, okay.
Mhm.
I can introduce all this data in order to make my best forecasting of the price, okay. But this data alone, okay, it doesn't mean anything, okay. For example, if the battery is not able to operate properly because have to, I don't know, it's in maintenance or something like that, okay. And for that reason, we also introduce this data in the EA model, okay.
No, yeah, I mean, yes. So you were talking about data, and I wanted to stress, like, for example, how does the tool handle like edge cases or high stress market scenarios, like, for example, price spikes or demand surges? How does the tool work with those sort of scenarios?
Uh, it's probably the most complicated thing of the tool. Okay, because these perfect scenarios are events that at the end the data that you had from the previous years. Okay, for example, we have three very complex years in the past 3 years. Okay, we found the Ukrainian war with the problem in the gas market, okay, that impact directly to the electricity market. We have also the pandemic year, okay, that was the opposite, okay, lowering the prices of the market and so on, okay. And also there is another component that there is a problem for most of the EA tools, okay, that is that the market has changed a lot, okay. It means when you make this kind of tool, you need a lot of data in order to train the tool. Okay, the problem was that the data before 2020, okay, in our opinion, most of this data is not useful in order to train the A model, okay, due to the new condition of the market from this year. Okay, the volatility is higher, the prices are higher, the technologies that are producing and selling energy in the market are completely different in terms of volume. Okay, at the end, before 2020, we have already aeolic and photovoltaic energy, okay, but not in volumes, okay, that impact too much in the market, but now it is the opposite. And there is another problem that we have not enough data in order to train these models um, of the behavior of the market once the storage has penetrated or will penetrate a lot in the market. Okay, is the other part that is still missing. Okay, so this is the first problem is that, okay, uh, there are not enough data in order, or at least usually the EA models are training with a lot of data, with a lot of years of data and so on. We only can use, okay, data from the 3 or 2 years ago. This is one point. Second one is the stochastic events or the sharp events, okay, that are, okay, we can find that in the last 3 years, 2 or 3 events with impact, okay, but we don't know in the next years how will be these events, okay. We only have to, or we only can to establish, okay, or to model, let's say, how will be the impact of this kind of events, okay, and a percentage of the of possibility of this event will occur. Okay, for example, we can predict that the next war inside the Middle East, okay, for example, could be in 2 years. Okay, and once we we going to this horizon, okay, this percentage will be higher and higher. Okay, that it doesn't mean that it will occur. Okay, but at the end is a question of risk, because at the end we are speaking about EA models,
Hmm.
markets, and so on. But the question at the end is that the owner of the plant or the operator of the plant, he only wants to make to limit the risk. Okay,
Yeah.
and this is the that we have to that we want to try to do. Okay, giving this information to the operators, to the owners. Okay, in order to give to them. Okay, there is a higher risk. Okay, that in the next 6 months, for example, this kind of events could occur. Okay, and it means that the price will drop below 20 euros, for example. Okay, and this is the
Hmm.
kind of inputs that you can give to them. Okay, this is the stochastic and probably the most complicated part of the model. Okay,
Yeah.
but it's not enough to give this data to the to the to the owner. Okay, you have to explain also this data to the owner. Okay, because
Okay.
in the end the people is looking for data, is looking for the figure. Okay, I have a lot of customers that ask to me, okay, which is Ignacio, who will be the price in the next year. Okay, I don't know. I can give to you a range of the price, which are the the my perspective. Okay, the trends and so on. Okay, but I can give to you 62.5 euros. Okay, because but the problem is that the people are looking for the fiber, but it's not the fiber itself. Okay, it's a range of prices with an explanation why the model of we are thinking that the range of prices can occur in the future. Okay, so for that reason, it's really important not to introduce all the data to make an AI model super powerful and this kind of things. Okay, you have also
Mhm.
to give this kind of explanation to the owners. Okay, and also take into account the the surrounding of the prices. Okay, the technology of the plants itself, the technology of the batteries, who will be the law or the regulations regarding the operation of the batteries, for example, okay, or if there will be change in the market, for example, okay, in order to give not only the figure, also if this if this figure could be the range could be greater, lower, and there are several risks that you have to take into account before to take a decision.
Yeah. No, exactly. I mean, there is always some degree of uncertainty when
Mm.
addressing these scenarios, obviously, and you need to take that into consideration. So yes, as my final question, what measurable impacts have early adopters of your solution, of the solution that you are developing, seen in terms of profitability or operational efficiency? Or if you have some data that you can share with us regarding prospective um, prospective gains in terms of efficiency or profitability.
Well, several point of view, because we can speak about the tool itself, okay,
Mhm.
taking as a isolated tool, okay. We expect that the difference, I don't know how to see in English, okay, but I mentioned it before, the difference between the average price in the market, okay, and the price that is captured by the photovoltaic producers, okay. I mentioned it before that in the last year here in Spain was the average of the price market was 62.5 euros per megawatt, okay. Probably maybe uh, I could be wrong for €1, okay, but the price captured by the producer, photovoltaic producer, was around €42. Okay, it means 70%. Okay, the objective with this tool is that the producers will capture at least the 95% of the average price of the market. Okay,
Okay.
it means that at the end it should be aligned with the market. Okay, but at the end it's a question to design this stack revenue. Okay, this
Okay.
is the first objective. Okay, the second one is to reduce to reduce the risk and the long term. Okay, because this market, we are speaking a lot of the daily market, okay, but there are a lot of producers that they are looking for their installation as an asset. uh,
Hmm.
for example, you can build a house, okay, and rent the house, okay, but at the end it's the same. Okay, I have an asset, I need or I want 7%, 8% of rentability, year rentability, and so on, or profitability. Okay, and for that kind of producers, usually they are looking for other parties inside the market in order to sell this energy, usually for the long term, okay, 5 years, 10 years, and so on, okay. And this producer needs, sorry, needs also this kind of production, okay, in order to sell this energy at the best price possible, okay. But for that, they need a price production. Sorry. And the second one, or the last one, is together with the rest of the partners of the project, okay, is to make easy the operation of the plant, okay, in this new reality. Okay, now, or in the previous year, the operation of the plant, the PV plant, is not really hard to do. Okay, it based basically to do a good forecasting of the production, for the production for the next day, and to sell this energy to the market. But now, because these new models of revenues, okay, it will be harder and harder and more complex. Okay, and together with the rest of the partners of the project, we have, or we are looking in order to make easier the operation to our potential customers. Okay, this is probably, even from my point of view, the most important or main objective of the project itself, together. Okay, because at the end, some people in the project are focused in the maintenance, some people are focusing to try to maximize the production. Some people is focusing in in the operation of the batteries. Some people is in the how to create a dashboard in order uh, to give the information to the customer and how is going the operation if the in the plants and so on. Okay, for me, is the most important objective of the project. Okay, and the AI tool. itself is really, really important in terms of profitability, or to give this information to the owner, okay, but it's part of some bigger, okay,
Yeah.
some big.
Yeah, no, definitely. I think that it complements very well with what the project is trying to achieve, which is obviously trying to improve efficiency for solar power plants, and definitely trying to predict what the market will do. Obviously, plays a huge role in that goal.
Thank you so much for listening to
Ignacio,
this
that's it for
episode.
today,
If you'd
and
like to learn more about the project and its solutions, please visit the pvop.eu website and join our community on Discord, okay? The link is in the description, and you can also follow us on social media on LinkedIn. We'll see each other in the next episode. Thank you.